All right, so we're going to be working on radical equations and inequalities. So what we're going to learn is how to solve equations containing radicals and solving inequality containing radicals. So vocabulary to keep in mind are what's a radical equation, what's an extraneous solution, and what is a radical inequality. So how do radical equations apply to manufacturing? So computer chips are made from the element silicon, which is found in sand. And suppose a company that manufactures computer chips uses the formula C equals 10 n to the 2/3 power plus 1500 to estimate the cost C in dollars in producing n chips. This equation can be written as a radical equation. So in order to solve radical equations, equations with radicals that have variables in the radicands are called radical equations. To solve this type of equation, raise each side of the equation to a power equal to the index of the radical to eliminate the radical. So let's take a look at an example. An example of this would be to solve radical x plus 1, right, all into the radical, plus 2 equals 4. So I'm going to go ahead and take the original equation, and I'm going to go ahead and start solving it. So the first thing I want to do is I want to get the radical all by itself. So I'm going to start by subtracting 2 from each side. So that'll give me radical x plus 1 equals 2. So remembering that only the x plus 1 is under the radical, right? So that's why we got rid of the 2 there. And now that I have radical x plus 1 equals 2, right? I have the radical all by itself. I want to get rid of the radical. I want to cancel out the radical. So what's the opposite of the square root? Would be to square both sides, right? Because the square and the square root and the square will cancel each other out, which leaves me just x plus 1 here. And then 2 squared is 4. And then I'm going to go ahead and subtract 1 from each side, and I get that x equals 3. So in order to verify, I need to check that this answer actually works in the original equation. So again, I'm going to substitute x with 3, my answer that I got, and check to see if it's actually equal. So I'm going to go ahead and do 3 plus 1, which is the square root of 4. Square root of 4 is 2. 2 plus 2 is 4. So does 4 equal 4? Yeah, it does. So it checks out. So that means that my solution is, in fact, 3, right? X equals 3 works as my solution. So the big trick here is getting the radical all by itself, right? Squaring it so that way you can get rid of the radical and then can finish solving it. Always check your solution to make sure that it actually works. So when you solve a radical equation, it's very important that you check your solution. Sometimes you will obtain a number that does not satisfy the original equation. Such a number is called an extraneous solution. So even though you found it to be your answer, sometimes it doesn't actually work. So that's what we call an extraneous solution. You can use a graphing calculator to predict the number of solutions in an equation, or to determine whether the solution you obtain is reasonable. So an extraneous solution, right? Let's look at an example. So I have the square root of x minus 15 equals 3 minus the square root of x. So I'm going to go ahead and take the original equation, and I'm going to go ahead and square both sides, right? And when I square both sides, that means I have to square this whole thing, right? So I put it in parentheses there. So when I square both sides of this, right, this will cancel out, leaves me with x minus 15. And on this side, I have to FOIL it like a polynomial, right? So it'd be like 3 minus radical x times parentheses 3 minus radical x, which 3 times 3 is 9. 3 times negative radical x is, and then combining like terms gives me 9 minus 6 radical x plus x. And then now I have to go ahead and continue to solve this. So I'm going to go ahead and subtract x from each side, and then subtract 9 from each side. So that leaves me with negative 24 equals negative 6 radical x. Divide both sides by negative 6. So I get 4 equals radical x. Square both sides, and I get x equals 16. So now I have found my solution that x equals 16. So I need to check it, make sure that it actually works. So take my original equation, substitute in 16 for x. So 16 minus 15 is 1, so the square root of 1 is 1, right? Square root of 16 is 4. So 3 minus 4 is negative 1. So 1 does not equal negative 1. So this did not work out. So what does this tell me? Well, this means that the solution does not check, so the equation has no real solution. And again, if I were to take these two equations and graph them on a graphing calculator, you could use Desmos, but any sort of graphing method would show me that these two equations don't ever touch, they don't ever cross. So therefore, they would never have a common x value. So you can apply the same methods by using solving square root equations to solving equations with square roots of any index. So not just square roots, but like third roots, fourth roots. And remember that to undo a square root, you square the expression. So to undo an nth root, you must raise the expression to the nth power. So let's look at an example. Let's look at a cube root equation. So 3 times the quantity 5n minus 1 to the power of 1/3 minus 2 equals 0. So in order to remove the 1/3 power, we're going to rewrite it as a cube root. So again, I'm going to take my original equation and go ahead and get the parentheses kind of on its own. So I'm going to go ahead and start by adding 2 to both sides. And then I'm going to go ahead and divide both sides by 3. And now I have this parentheses to the 1/3 power. So remember our exponents, our rational exponents, I can rewrite that as our exponent rules, right? So I can go ahead and raise it to the 3rd power, right? Because power to a power, I'd multiply those. So that would make it to the 1st power, which leaves me just 5n minus 1. 2/3 to the 3rd power would be the same as just doing the 3rd power of each one. So 2 to the 3rd power is 8, 3 to the 3rd power is 27. And then I would go ahead and add 1 to both sides, right? So that would leave me with 35 over 27. Divide both sides by 5, or multiplying by 1/5. And that would give me n equals 7 over 27. So again, I'm going to go ahead and check in my original equation, make sure it works. Substituting my value in, right? Go ahead and simplify. And I would get that 0 equals 0. So it does in fact check out. So make sure that you check your solutions. So this one does check out. And then let's go ahead and look at solving radical inequalities. You can use what you know about radical equations to help you solve radical inequalities. A radical inequality is an inequality that has a variable in a radicand. So here, let's look at this example. You have 2 plus the radical quantity 4x minus 4 is less than or equal to 6. Since the radicand of a square root must be greater than or equal to 0, right? It can't be negative inside of the radical. First, solve 4x minus 4 is greater than or equal to 0 to identify the values of x for which the left side of the given inequality is defined. So again, just knowing that the radicand has to be positive, right? You can't take the square root of a negative. It's not going to work, or it's not going to give us a real number anyways. So 4x minus 4 has to be positive, so it has to be greater than or equal to 0, right? So add 4 to both sides, divide both sides by 4, and you get x must be greater than or equal to 1. And then now we're going to go ahead and solve the original inequality. Again, let's get the radical by itself. So subtract 2 to both sides, right? And then I'm going to go ahead and square both sides. And then I'm going to go ahead and solve for x. So add 4 to both sides, divide both sides by 4, and I get x is less than or equal to 5. So I know that x has to be greater than or equal to 1 and less than or equal to 5. So those are my two inequalities, right? So it appears that x must be greater than or equal to -1 and less than or equal to 5. You can test some x values to confirm the solution. So again, if we took our original inequality here and tested it for those values that we got, right? We can test 0, we can test 2, we can test 7, right? 0 being less than 1, 2 being greater than 1 but less than 5, and 7 being greater than 5. So again, testing that when you plug in 0, it doesn't work. If you plug in 2, it does work. And if you plug in 7, it does not work, right? So this does prove that we have all those points in between. So the solution checks that only values in between 1 and 5 or equal to 1 and 5 will satisfy the inequality. You can summarize a solution on a number line saying that all the values equal to 1 and greater than that, or equal to 5 and less than that, all those values in between will be the solutions for this inequality. So here is the summary of that concept. To solve radical inequalities, complete the following steps. If the index of the root is even, identify the values of the variable for which the radicand is non-negative, right? It has to be positive, right? Greater than or equal to 0. Step 2, solve the inequality algebraically, just like we did with equations. And step 3, test the values to check your solution. All right, thank you guys for watching. Let me know if you guys need anything else.